All right, so for 2009, it says, given that X and Y are negative numbers and X is greater than Y, which of the following is true? All right, so they said X and Y are negative numbers. So you can always picture it inside the head right here. X and Y is negative number. So let's use some numbers like -3 is greater than -4. Let's use some example, right? When you square both sides, you would notice that 9 is going to be less than 4 squared, which is 16. And so therefore, when you have negative numbers and you have X is greater than Y, when you square it,
Y will be greater than X.
X squared is going to be less than Y squared. And that's all it is for number 1. I sent you the solution in the chat, so you can also follow the solutions from the chat as well. And so this is the first one. X squared is less than Y squared. X squared is less than Y squared, which is D. So that's the first one. Easy question. Warm up one to start with. Then now the next question says, what is the log of base 5 of the number 5 root 5? What is that equal to? So that's what we're going to do. They have log of 5 with 5 root 5. All right, so the first thing you can do is let this be equal to P. And we're going to solve for P. I like to equate it to P. So just let it be equal to P. All right? Then using the first rule of log, what is a log? The log of a base of some number is equal to a power, where if this is true, then it's pretty much telling us 5 to the P is equal to 5 root 5. So 5 to the P is equal to 5 root 5. But now 5 root 5 is really 5. 5 can be written as 5 to the 1 times. Now root 5 is just 5 to the half power. That's root 5. Root 5 is 5 to the half power. Now when the bases are the same, you can add the powers. And so 1 plus a half is 3 over 2. And so 5 to the P is equal to 3 over 2. And so therefore P is equal to 3 over 2. Since P is 3 over 2, then the log of 5 root 5 is 3 over 2. So the answer is 3 over 2. So that's the answer, 3 over 2. That's clear?
Yes, sir.
All right, so that's number 1 and 2. So they start pretty simple. Now question 3. Question 3 is very easy. Question 3 gives us that f of x is equal to x times 1 minus x. All right, so if you have x times 1 minus x, this is just a quadratic, because if you expand it, you get x minus x squared. So you have x minus x squared, and the roots are 0 and 1. So they cut the x-axis at 0 and 1. Since it's a quadratic, a is out. And then the coefficient of the x squared term is negative, so we know it frowns. And so therefore the answer is B. All right, that's good?
Yes, sir.
And so that's f of x equal to x times 1 minus x. Now, question 4. Now this, we're going to have to use the table to answer the question. It asks for G inverse of f of 3. So first we have to do is find f of 3. So f of 3, we need to look when x is 3. When x is 3, we get
F is 2.
Yes, so therefore f of 3 is 2. And so now we need G inverse of 2. To solve G inverse of 2, we're pretty much solving g of x equal to 2. And so when g of x is 2, the corresponding x value is 5. And so g inverse of 2 is 5. That makes sense?
Yes, sir. It's the first time I heard that the inverse is basically equating g of x to 2.
Yes, that's what we do. All right, you're pretty much set in g of x equal to 2. And then we look at the table when g of x is 2, which is 5. And so that is 5. So anytime when them ask you for g inverse of something, let's say them ask you for g inverse of 3. You look where the table is, g of x equal 3, and so g inverse of 3 would be 0. What if they'd ask you what is g inverse of a half? What's g inverse of a half?
G inverse of a half would be two.
2. Very good. G inverse of a half would be 2. And it's just as that. All right, think about it. It makes sense. G of 2 is equal to a half, and so G inverse of a half must equal to 2, because they're inverse relationships. All right, and so I think I would have worded it nice for you in the solution. So in the solution, this is the solution. How I word it for you to understand. So f of 3 means when x is 3, we want f of x equal to 2. So f of 3 is 2. And so g inverse of f of 3 mean we want g inverse of 2. And g inverse of 2 is just 5. We're solving. So it's worded better right here. So instead of listening to everything that I'm saying, it's nicely worded right here. All right. So that's C. Now this question says the range of values of x that satisfies this inequality. So we want when the modulus of x minus b is greater than a. So we want where the modulus of x minus b is greater than a. So we have the modulus of x minus b. We want when the modulus of x minus b is greater, is it greater or less than? It's less than a, not greater. So and then the modulus of x minus b is less than a. And so the first thing you can do is square both sides. So we have x minus b all square is gonna be less than a square. That's the first thing you do. Next thing you do is expand this bracket. And so when you expand it, you get x squared minus 2xb plus b squared, and that's less than a. And so now we want less than a squared. So we can bring this over to get x squared minus 2xb plus b squared minus a squared is less than 0. So that's what we want. And so therefore we can factorize it. Less than 0. In order for it to be x squared, it has to be x and x. All right, now this, how are we going to get this, what we need right here? All right, so it's plus b squared minus a squared. Now in order for this term to be b squared minus a squared, it has to be b minus a and b minus a. So b minus a is going to go right here. And the other one would be b plus a, because that's the difference of 2 squared. All right. And you put minus. So you're pretty much just factorizing it. All right. And you put plus. And so what we end up getting is that x is going to be between the two of them. And so if x is between the two of them, all right, how we know that it's between it, by the way? Well, right here, if we have x minus a times x minus b is less than 0, I just want to show you what happened graphically. This is what happened graphically. If I have x minus a less than 0 and x minus b less than 0, let's say this is the graph, and this is the point A, and this is the point B. It's a quadratic. We have A, and we have the point B. Now, for when it is less than 0, it is inside of here. This is the graph inside of here. That's the quadratic graph. The quadratic graph is inside here. The quadratic graph is below the x-axis when x is between A and B. All right? And so x is between the smaller one and the bigger one. So x is between, this looks like, this is going to be A plus B. So x is between A plus B, and this one is going to work out to be minus B plus A. And so x is between minus b plus a and a plus b. That's what x is between. All right? That's one way to do this question. That's method one. Method one. So I'm going to write M1. That's method one. There's another way to do these modulus questions very easy. I'm going to write it right here. So if you have the modulus of x minus some number n, if the modulus of some number x minus n is less than some big number n, or let's use a different letter, let's use p, then x minus n is between, so this is some rules you can study, then x minus n is between p and minus p. That's one rule. Also, so these are just some rules you can know. It's good to know them so it makes you work out these questions easier. Also, if x minus n is greater than p, then the modulus of x minus n, not the modulus now, so we get rid of the modulus. The modulus of x minus n is greater than p, then x minus n is going to be less than negative p, or x minus n is greater than p. All right? And so using this method to work out where them tell you that x minus b, the modulus of that is less than a, then what we can then do is just say x minus b, instead of squaring both sides, using this rule, then x minus b is going to be between a and minus a, and they will add b to both sides, add b to both sides, and so what we get is x is going to be between a plus b and b minus a. So add b to both sides. A is between a plus b and b minus a.
Wait, don't you mean a minus b?
Carry over the plus b, a plus b. Carry
Yeah.
over the b minus a. It should be b minus a.
Oh, okay, yeah.
B minus a. And so that's it. So x is between b minus a and a plus b. A plus b and b minus a. Here is b minus a, but they write it as minus a plus b, but that's the same as b minus a. And so a is the answer. Now this question is a third question where you pretty much has to just rationalize the denominator. Anytime the square root is in the denominator, you rationalize it to get rid of the square root out of the denominator. And so in this question, we have 4 root x plus we have 4 root 3x over the root of 48. Now the root of 48 can be broken down as 12 times 4. Or we can even go further to say 48 is 16 times 3. So if 48 is 16 times 3, right? Then this can pretty much simplify to be 4 root x plus 4 times the root of 3x divided by, now this root 48 can be broken down as the root of 16 times the root of 3. Now the root of 16 is 4. And so 4 cancel this 4. And so what this works out to be is 4 root x plus, so this 4 cancel this 4. Now we have root 3x over root 3. But look at this. I can write this as root 3
times
root x over root 3. And so that root 3 cancel this root 3. And so what I end up with is 4 root x plus root x, which is 5 root x. And that gives you that answer. So that's 5 root x for number 6. Five root x. Easy question, easy. Easy like Sunday morning, right?
Oh.
All right. Now this question says, given that x minus p all cube minus q squared times x minus p is equal to 0, find the values of x. So all they're pretty much asking you to do is to solve this equation, right? And solve for the values of x that makes that equation to be true. So that's what we're going to do. X minus p all cube, x minus p all cube, that's minus q squared times something, times x minus p, and that's equal to 0. All right, so the first thing we can do is notice that we can factorize out x minus p. So if we factorize out x minus p, right, what we're left back with is this becomes x minus p all square, x minus p all square minus q square. So that's what we have, because when you factorize x minus p from this, you just get back 1. So that's what we have. Now inside here now becomes the difference of 2 squares, where if you have a square minus b square, then it's a minus b times a plus b. So we can factorize it some more to write x minus p times, this part can be written now as a, this is your a is x minus p, a minus b, which is minus q, times a plus b. So you write okay, a x minus p plus a b, which is q. So it becomes plus q. That's equal to 0. Now, if the product of 3 terms is equal to 0, then one of them has to be equal to 0. So then pretty much we're solving is x minus p equal to 0, or x minus p minus q is equal to 0, or we're solving x minus p plus q is equal to 0. So if we're solving these now for x, From the first one, we're going to get x is equal to p. That's from the first one. X is equal to p. From the second one, we get x is equal to p plus q. And from the third one, what we're going to get is x is equal to, that looks like, bring over, we'll get p minus q. So these are the three solutions. X can be p, x can be p plus q, or x can be p minus q. So x can be p plus q, or p minus q. And that is C. So easy. Easy. Very easy. The next question now. So we all clear with this one? All right. So now the next question is, it says the range of values of x for which 2x plus 3 over x is greater than or equal to 8. That's a CSEC math question. Shouldn't be on the CAPE paper, but let's do it anyway. It says we have 2x plus 3 over x, and they told us that this is greater than or equal to 8. So the first thing we can do is cross multiply, and so this implies that 2x plus 3 is going to be greater than or equal to 8x. So then now we need to bring all the x's on one side. So we'll bring the 2x over here, and so we're going to get 3 is greater than or equal to, bring the 2x over here to get 6x. Then we divide both sides by 6 to get 3 over 6 is a half is greater than or equal to x. And so that's the solution. We always want x facing, you always want x to be the first one. So you can rewrite that as x is less than or equal to a half. So that's the solution for this question. X is going to be less than or equal to a half. That's A. Easy, soft. All right, this question now. This question goes further to ask us a logarithm question. And it says that we have log of base A of 4 plus log of base A of x minus log of base A of 7 is equal to 2. And they want us to find the value of x that would satisfy this equation. So in order to solve log question, you need to either write everything as a log or you take everything out of the log form. So either way we can do it. Let's write everything as a log. So we have log to base A of 4 plus log to base A of x. Then it says minus log to base A of something, which minus log to base A of 7, minus log to base A of 7, and they said that's equal to 2, and we're solving to find x. So I can rewrite all of this as log to base A of, now the laws of log says log A plus log B is log AB, so I can multiply them and write it as 4x. But this has a minus, so this is going to go in the division part. And so I have log of base A of 4x over 7, that's equal to 2. Now applying rules of log that we know, that this is pretty much saying the base to the power. So it's saying now that A squared is equal to 4x over 7. And they want the value of x. And so what I can do then is cross multiply the 7. And so I get 7a squared is equal to 4x. And then I can divide by 4. And so what I'm getting now is x is equal to 7 over 4 a squared. 7 over 4 a squared. That is the value for x. 7 over 4a squared. Easy, easy, easy question. 7 over 4a squared, which is b. All right. That's question 9. We'll go to question 10 now. It says the point 1, 1 lies on the curve y equal to f of x. Under which of the following transformation is 1, 1 invariant? So it means that no matter what, the point 1, 1 remains the same. Now, when you take the inverse, it's going to remain the same. Let me tell you why. It remains the same because f of x is y and f of x is 1 when x is 1. All right? And so it remains the same under this one. I'm going to do it on the white screen soon. So it remains the same under I. Now, both of these numbers are already positive. And so it remains 1 right here as well. And 2f of x minus 1, that would be 2 times 1 is 2, minus 1 still give us 1. And so it remains the same for these three, 1, 3, and 4, which is D. Let's look at y now. We want when it is remaining invariant. So we have the point 1, 1, right? So what this is telling us is when x is 1, y is 1. That's what it's telling us. When x is 1, we don't have to say y, we can say f of x. When x is 1, f of x is equal to 1. All right? Now, what do we know about the relationship between inverse and a function? We know that if y is equal to f of x, if y is equal to f of x, then the inverse we'd say is x. All they tell you is to interchange x and y. And so then you'd interchange by saying x is then equal to f of y in this case. They interchange x and y. All right, but notice that when f of x, what is f of x? F of x is equal to 1. What is x right here? X is 1. So either way, when you work out the two, both of them, you're going to get that the coordinates is 1, 1. So for either the function or the inverse, you're going to get 1, 1. And so that is why I is true. Now, they had now 2f of x. I'm just going to write 2f of x minus 1. And they want the modulus of that, right? So now look at when x is 1. This common mean of 2 times 1 minus 1. And 2 times 1 minus 1, that's just equal to 1. And so therefore, y is equal to 1. And so this proves why 4 remains the same. All right? And so, and then modulus now we clearly know that we don't need to change anything because they're both positive. And so 1, 3, and 4 is the answer. Now this question asks us which of the following is true. All right, so for a cubic equation, let me just write this down before we even look at the question. For a cubic equation, right, so if the roots of a cubic equation, if the roots are alpha, beta, and gamma, so these are the roots of a cubic equation, then you can always write the cubic equation in the form x cubed minus sx squared. What does this s mean? This s just means sum, where s is equal to alpha plus beta plus gamma. So I like to write s. P2, which I call product by 2, is when I group the product of 2 of the roots. So this is alpha beta plus alpha gamma plus beta gamma. And then P3 is what I call the product by 3, the product of all the roots, alpha, beta, gamma. All right, so a quadratic equation can be written in the form x cubed minus sx squared plus p2x minus p3 equal to 0. That's how we can write a cubic equation. We can always write a cubic equation in that form. And so let's look at this question. This question is telling me, it's asking me now, from the cubic equation, what is the sum and what is the product by 2? Well, first thing, we need to divide through this equation by 3. And so dividing through this equation by 3, we then get the x cubed. And so the sum is going to be 4 over 3. Following the form, it should be x cubed minus sx squared. So this is the x, 4 over 3. Plus the product by 2 is going to be 7 over 3. But then it have a minus here, and it should be a plus. So I'm just following this form, how we write the cubic equation. That's the form we're looking at. And so what we're getting is the sum is 4 over 3, and the product by 2 is minus 7 over 3. So 4 over 3 and minus 7 over 3, that is C. Easy, soft, or as you would say, easy like Sunday morning. Now this question now, it gives us an inequality, and it says find the value of x that satisfies this inequality. I'm not going to be squaring both sides, that is too long. I'm going to show you the easy method that we just talked about for modulus. So we have the modulus of 2x minus a is greater than the modulus of x. You can go ahead and square both sides, factorize, get a nice little quadratic equation, and then it works out. But the easy way is right here. Here's the easy way. If you have the modulus of x minus n is greater than p, then x minus n is less than minus p, and x minus n is greater than p. So that's the easy way to do it. Let's do the question now. We're going to do it the two ways. We're going to do it the easy way, and we're going to do it the expanded way. So 2x minus a is greater than x. The modulus of 2x minus a is greater than the modulus of x. Method 1, most persons want to square both sides. So if you square both sides, you're solving 2x minus a. I will square both sides to get rid of the modulus. So 2x minus a is greater than x squared. And so then we expand this square bracket to get 4x squared minus 4xa plus a squared is greater than x squared. See how method 1 long, method 2 done already. So then now we can bring over this x squared to get 3x squared minus 4xa plus a squared is greater than 0. So then we reach a part where we can factorize the quadratic now. And so we factorize it. So what we end up, if we get 3x squared, it's going to always be 3x and x. So listen to me, people. We're big people. We don't need to be splitting the middle term. So this is how you factorize without splitting the middle term. Look on the first one and look on the last one. What we multiply if we get 3x squared? Must 3x and x. And then what do we multiply to get a squared? It has to be a and a. You put minus and minus. That's how we factorize it. All right. And so therefore, what we're going to get is that x is less than the first one. X is going to be less than, this would be working out to be a over 3, comma, and then x is going to be greater than the second one. X is greater than a. So that's the answer using method 1. All right. The alternate method would have just been to write that. So 2x minus a is less than minus x, but greater than x. So this is method 2. Let me write it down. Put some space right here. That's method 1. This is method 2. For method 2, what you then just say is 2x minus a, it's less than minus x, or 2x minus a is greater than x. That's method 2. So when you're solving the first one, you bring over the x, you bring over the a, you get that x is going to be less than a over 3, or, so using set notation, that's or, the u, or x is going to be greater than, from the second one, we bring over the x, bring over the a, or we get x is greater than a. So that's method 2, very easy. You just write 2 lines. Method 1, you're doing a whole lot of stuff. All right, but either way you choose to do it is fine. So x is less than the first one, a over 3, or x is greater than a. So that's number 12, a. Number 13, it gives us that alpha, 2 alpha, and 3 alpha are the roots of this cubic equation. So if you're given the roots of this cubic equation, all right, and listen what they told us about this cubic equation. The cubic equation is x cubed plus kx squared plus 48 equal to 0. Find the value of the constants. We can find the value of the constant because we know that the sum of the roots is minus k, and the product of the 3 roots is negative 48, because we know that about roots. We know that it can be written in this form. And so when they give us this now, talking about x cubed plus kx squared plus 48 is equal to 0, what they're pretty much telling us then that the sum is minus k, and minus k is equal to the 3 roots. The sum of the 3 roots, which is alpha plus 2 alpha plus 3 alpha. So that's the sum of the 3 roots, alpha plus 2 alpha plus 3 alpha, which is just going to be 6 alpha. So 6 alpha is equal to minus k. All right. The next thing they told us is the product by 3. The product by 3 of the roots is going to be alpha times 2 alpha times 3 alpha. When I multiply that, I would get 6 alpha cube, and 6 alpha cube is equal to negative 48. So if 6 alpha cube is equal to negative 48, what that implies is that alpha is going to be equal to negative 2. Because if we have negative 2 right here, negative 2 cube is 8. 8 times 6 is negative 48. So alpha is negative 2. If alpha is negative 2, it implies that we can plug alpha right here now to get that minus k is going to be equal to 6 times negative 2. And so therefore, k is equal to 12. Because the negatives on both sides cancel. So k is equal to 12. And that's that question. K is equal to 12. All right, question 14. Question 14 says that the two functions f and g are defined such that f of x is 2x plus 1, and x is between 0 and 10, and g of x is between 0 and 3. The composite function can only be formed if the domain on f is restricted to the domain of f is between 0 and 10. And so the function will always be formed under the domain of f. And so the domain of f is 0 and 10. And so between 0 and 10 is the answer. Now this question, the only trick that they're asking you is pretty much asking you what is the domain of the inner function. All right, a composite function can only be formed under the domain of the inner function. And so if I had told you that g of f is defined such that the domain of f is integers and the domain of g is real, then I ask you, what's the domain of the composite function? It's going to be the domain of f, which would be integers. So a composite function can only be formed under the domain of the inner function. That's the key thing to remember. A composite function can only be formed under the domain of the inner function. The inner function in this case is f, and so the domain of g of f is f, which is between 0 and 10. And that's it. That's number 14. Easy question, soft. All right. Now this question says the number of visas issued by an embassy annually is given by v of x, which is 7x squared, minus 42x plus 72. All right, so this is pretty much a practical applications of functions. All right, so some visa embassy use a function to look at or analyze the amount of visas that they're issuing per year. All right, so this is just a practical applications of functions. All right, how we use maths in everyday life. And they want us for the least number of visas that they will issue. Notice that this is a quadratic. And so in order to get the least number of visas for a quadratic, you're going to have to find the turning point. So there are two ways to do this question. You can either complete the square. Well, there are three ways to do this question. You can either complete the square, or you can either use the formula method, or you can use differentiation. So they tell us v of x is 7x squared minus 42x plus 7. So that's 7x squared minus 42x plus 72. So let's say we're completing the square. To complete the square, we factor out the 7 first, and we'd have x squared. 7 from 42 is 6, so we'd have minus 6x. That's the first step, plus 72. The next thing we then do is say, all right, it's still 7. So next thing we do is half what's inside the bracket. So we half it to get x minus 3 squared. Then we'll subtract back 3 squared. So subtracting 3 squared, subtracting 9 plus 72. You then expand this bracket now to get 7 times x minus 3 all squared. Then 9 times 7 is minus 63 plus 72. And so this works out to be 7 times, this is if you're completing the square algebraically. So you'll get 7 times x minus 3 all squared, then 72, and minus 63, that is just plus 9. And so the least number of visas issued is this, 9. So the least number of visas is this, the minimum. This is the minimum value. So the least number of visa issued per year is 9. All right? That's the least number of visas issued. Alternately, an alternate method is differentiation. If that is v of x, you could then go further to say, all right, v prime of x is equal to 0. That's when a minimum point occurs. So this will give us the minimum. A minimum point occurs, or a stationary point occurs, when the derivative is equal to 0, the first derivative. And so from that, we could differentiate this to get 14x minus 42 is equal to 0. Solving this equation, we would end up get that x is 3. And so the minimum point occurs when x is 3. And so all we'd have to do is solve and find v of 3. V of 3 gives the minimum value, which would be 7 times 3 squared minus 42 times 3 plus 72, which is going to be equal to 9. And so the least number of visas is 9. That's using calculus. That's the least number of visa issues. That is if you want to use calculus. This is if you want to use completing the square. If you wanted to use formula method, then you could go ahead and find xt using the formula minus b over 2a. And you don't even need to find xt, you just need to find yt. Yt, I think, is given by 4ac minus b squared over 4a. So you use that to find the minimum value. Using the formula method where the coefficient of a, the a is 4, c is 72, b is 42. When you work all of this out, you're going to get 9. All right? So either way you want to use method 1, or you want to use method 2, or you want to use method 3, you still get the same 9. All right? So 9 is the least number of visas issued in a particular year. All right? Okay, question 16 now. Question 16 is a graph question. How to sketch the graph of sine 2x. So to sketch a graph of sine 2x, what I like to do is to draw a table. Why draw a table, you might ask? Because this, you can never go wrong with a table, because you're going to be sketching values that you know. So when you're going to draw the graph of sine 2x, I want you to write down x in a table and then sine 2x. Then ask yourself, what is the sine of 0? Or what is sine of 2 times 0? So when x is 0, the corresponding y value I'm getting is 0. The next thing you go up is to 30. 30 degrees is pi by 6. And so you go pi by 6. Then you go pi by 4, which is 45. Then you go 60, which is pi by 3. Then you go 90, which is pi by 2. This is just the table we're filling out. Then you go pi. You don't need to go anymore because you get to see the pattern. All right, so when you have pi by 6, 2 times pi by 6 is pi by 3. And the sine of pi by 3 is root 3 over 2. So right here, the corresponding value is root 3 over 2. Then you put in pi by 4. 2 times pi by 4 is pi by 2. And the sine of pi by 2 is 1. Put in pi by 3. So you get the sine of 2 pi by 3, which is the sine of 120. And the sine of 120 is root 3 over 2. You put in pi by 2, you get the sine of pi. The sine of pi is 0. And then you put in pi, and you get that the sine of 2 pi is also 0. So we can do a little rough sketch right here now because we have enough values to see what's happening. So this is our sine graph. So sketching it. So we'll start from 0. Start from 0. We know when x is pi by 2, we also get 0. So you can put your pi by 2. You know when x is pi by 2, you get 0. You know when x is pi, you get 0. You know, so when x is pi by 4, you're going to get 1. And so when I need to draw not more, because this is a sine graph is sino synodual. I'm not pronouncing the word correct, or synodual, in the sense that if you can sketch between 0 to pi by 2, it's just a reflection in the x-axis for pi by 2 to pi. And so this is the sign of, this is a graph of y equal to sine 2x. So this is now the graph of y equal to sine 2x. And that's where I use the domain being between 0 and pi. All right, so whichever one looks like this, then that's a graph. So just go to the question now. And that's the same domain they use between 0 and pi. So let's look back at the graph that we draw. So now at pi by 2 we're supposed to get 0, and at pi we're supposed to get 0. So at pi by 2 we get 0. So this one, pi by 2 is 0. But we shouldn't have any negative value before pi by 2. And so, first of all, let's take out which one we know it cannot be. It cannot be this one, because this one have 2 and negative 2. So this one is out. So put a x, that's out. This is it, A. There we go. That's our graph. So it was the first one. Easy question. That's a graph of y equal to sine 2x. All right, now this value, this we don't even need to work out. Clearly this is cosine p. How do we know it? Because you have to use the compound angle formula to expand this. So the sine of pi by 2 plus p, using the compound angle formula, the sine of pi by 2 plus p, the sine of pi by 2 plus p, it's going to be equal to the sine of pi by 2 times the cosine of p plus the cosine of pi by 2 times the sine of p. However, the cosine of 90 is 0, and so that part is automatically 0. The sine of pi by 2 or the sine of 90 is 1, and so we'll just get cosine p. So the answer is cosine p. Easy question, soft. Easy question, soft. All right. Now this question asks us, what is 1 over cosec square x? When you're evaluating what is 1 over cosec square x, what you're going to have to do is look how I'm going to write 1. So 1 over cosec square, all right? 1 over cosec square. Well, first of all, what is cosec square? Cosec is 1 over sine. And so this becomes 1 divided by 1 over sine square x. Now 1 over sine square x is sine square x over 1. So that's what we have now, sine square x over 1. But I'm not going to write 1. All right, so I write 1. But what is 1? 1 is, so look how I'm going to write 1. 1 is cos square minus sine. 1 is sine square plus cos square. So that's how I'm going to write 1. 1 is sine square x plus cos square x. We know that that is 1, and so I did not tell any lie. I did not make something up. Now, after I did that, now I want everything to simplify out in terms of tan or cotangent based on the answer, or something with secant. So what I'm going to do is you can either divide through by cos square x, or you can divide through by sine square x. I'm going to divide through by sine square x. And I'm going to divide both the numerator and the denominator by sine square x. Now dividing both the numerator and the denominator by sine square, I get sine square over sine. No, let's not use sine square. Let's use cosine square, because then that's just going to give me back 1. So I want to get something with tan and cot. So I'm going to use cosine square. So follow now. Sine square divided by cos square is sine over cos, and that gives me tan square x. So that gives me tan square x divided by, now sine square divided by cos square give me tan square x plus cos square divided by cos square is 1. So am I finished? No, I am not finished. But then I know that sec square x is equal to 1 plus tan square. Ah, sec square is 1 plus tan square x. And so therefore the final answer is just tan square over sec square. So this is tan square x divided by sec square x. Because tan square plus 1 is sec square. So I get sec square x. So tan square over sec square is the answer. Tan square over sec square, which is C. Easy stuff. All right. Now this question 19, it gives us P, and it is asking us to work out the expansion of P. So to work out the expansion of P, all right, first and foremost, to work out the expansion of P, it's always best to have them in terms of sine or in terms of cos. But right here we have sine square and cos square. So we can factor out the 2, and sine square cos square is 1. And so what we end up with is 2 times sec square tan square. Let's just write it down so we see it. So it tells us P is equal to 2 sine square theta plus cos 2 cos square theta. So that's what I'm talking about. We can factor out 2 from right there. So we have 2 times sine square theta cos square theta times, what was it being multiplied by? Sec minus tan? Yes, sec minus tan. Then it's being multiplied by sec squared theta minus tan squared theta. Sec squared theta minus tan squared theta. So first and foremost, we recognize that we can factor out 2 from right here. When we factor out 2, we're going to be left with sine square plus cos square, which is 1. So we get 2 times 1 times sec square theta minus tan square theta. All right, don't freak out. We just told ourselves that sec square theta, so let's go back. We just worked out that sec square is 1 minus tan square, 1 plus tan square. So since sec theta is 1 plus tan square, then what we can then write this as is 2 times, in bracket, this sec square theta becomes 1 plus tan square theta minus tan square theta. That's sec square theta. And so when we work this out, we have tan square theta minus tan square theta. And so we get 2 times 1 is 2. 2 times 1 is 2. So that's the final answer. The final answer is 2. Easy stuff, very easy. All right. Now this question, which is a vectors question now, which is the best topic in pure mathematics. Just want to point that out, vectors. It is saying that we have the vector PQ is perpendicular to the vector 3 minus 1. 2 vectors are said to be perpendicular when their dot product is equal to 0. That's when 2 vectors are perpendicular. And so PQ dot 3 minus 1 is equal to 0. And since their dot product is equal to 0, what we end up have is 3p minus q is equal to 0. So that is it. 3p minus q is equal to 0. That's question 20. Easy stuff. All right. Now this question, question 21, it says we have 1 plus cos to the 4th power of a minus sine to the 4th power of a. What is that equal to? Well, you can always break down this to the 4th power and to the 4th power for both cos and sine. We don't like to work with such high powers. We like to work with something like 2 and 1. Those are easy powers to work with. And so if we have 1 plus cos to the 4th power, so we have 1 plus cosine to the 4th power of a minus sine to the 4th power of a. So if that's what we have, we can always rewrite this as 1 plus this cosine to the 4th power we can write as cos square a square minus sine square a square. Because when you square them, when you square the 2nd power, you're going to get back to the 4th power. But now, when we have it like this, we can write it as the difference of 2 squared, so it becomes 1 plus the difference of 2 square formula difference of 2 square formula is going to be a minus b, so that part will work out to be cos square a minus sine square a all right, and then we can write this now as cos square plus sine square. That's the difference of 2 square formula. So then this is now cos square a plus sine square a. And so you have cos square a times sine square a. Now cos square a sine square a is 1. And so what we end up with is just 1 plus cos square a minus sine square a. Now cos square a minus sine square a is 2 cos 2a. So it becomes 1 plus 2 cos 2a. That's the answer. 1 plus 2 cos 2a. Cos 2a. All right. Oh, not 2 cos 2a, cos 2a. Now let me see. 1 plus cos 2a is not there. 1 plus cos 2a is not there. But then we know several identities for cos 2a. 1 plus, now what is cos 2a? Cos 2a can also be written as 2 cos square a minus 1. So this is a very good question. And so when you expand this now, the 1 plus the minus 1 only leaves 2 cos square a. So 2 cos square a is the answer. That's a nice question. This is a very nice question. So that is A. Well, not A. Here it is. 2 cos square A. That is B. All right. So that's question 21. Question 22. It is asking us for an expression for all right. All right, so it's asking for the cotangent of x It's asking for the cotangent of x and the sum with the tan of x. So in order to get the cotangent of x plus the tan of x, and we need it in terms of sine and cosine based on the options, right? So based on the options, we need to get it in terms of sine and cosine to determine the answer. So let's do that. Cot x plus tan x. So we're going to write the cotangent of x plus the tan of x. I'm going to rewrite this now as I can rewrite the cotangent of x. The cotangent of x is the cosine of x over the sine of x. That's the cotangent of x. Plus, the tan of x can be written as sine x over cosine x. So we have sine x over cosine x. All right. So now that we have cosine x over sine x plus sine x over cosine x, we need to join them as one fraction. So we need to join them as one fraction. And so that's what I'm going to do right here. So the equivalent denominator is going to be sine x cos x. And so then we just need to say sine x into sine x cos x, leave cos x. And so what we end up getting is cos square x plus sine square x. Now cos square x plus sine square x in the numerator is 1. And so what we end up with, the final answer is 1 over sine x cos x. Now, when you get 1 over sine x cos x, more than likely they're not going to put that. So look at this. First and foremost, if I put a 2 right here and put a 2 in the numerator, these two cancel each other. But then 2 in the denominator makes this 2 sine x cosine x, which is sine 2x. And so this works out to be 2 over 2 sine 2x. This 2 shouldn't be there. So this is 2 over sine 2x. Now, 2 over sine 2x can also be written as 2 times 1 over sine is cosec. So it's 2 cosec 2x. 2 cosec 2x. And that is the cotangent of x plus the tan of x. So that is 2 cosec 2x, which is C. So we just reached halfway in the paper. And so we have half more of the paper to go. All right. And then now this question is giving us the normal at the point P. And the normal at the point P is the point 43. The normal at P to the circle that is has a gradient of 3 over 4. All right. And they're asking now for the equation of the tangent. The equation of the tangent, if the gradient is 3 over 4 for the normal, then the gradient of the tangent is going to be minus 4 over 3. So you look whichever one has minus 4 over 3. All right. So because the gradient of the tangent, so this was the key part. Normal. And this is the gradient of the normal. And so the gradient of the tangent is going to be the negative reciprocal of this gradient, which is minus 4 over 3. So that's A. Question 24. It gives us the line through the points P and Q is parallel to the line with equation 3x plus y minus 21. So I'm going to write down that line 3x. So let's say we have a line. So I like to put it on graph. I love when we can see it on graph, right? So we have some line that is 3x. So this is the line 3x plus y minus 21 is equal to 0. That's the line they give us. And so if I bring this over, the actual line is y is equal to 21 minus 3x. Y is equal to 21 minus 3x. So if you have the line y equal to 21 minus 3x, it passes through the point 21 and a gradient of negative 3. So this is the line then. Let's say that's the line. This is the point. This is the point 21. All right, so that's one line. They say another line is perpendicular to it, and the other line, not perpendicular, parallel to it. You have some line that's parallel to it, and that parallel line passes through P and Q. So you have a parallel line that passes through P and Q, and so this is the parallel line now. Let's sketch a line that's parallel to it, that passes through P and Q. So this is a parallel line. All right, I have a point P and Q. So I'm just going to put some dot now to represent P and Q. So this is your point P and your point Q on this line. They told us P is the point 2K or K2 and Q is the point 68. So P is the point K2 and then 68. So P is the point K2 and this is the point 68. Then they ask us, what is the coordinate of K? Well, first and foremost, if two lines are parallel, then they have the same gradient. And so the gradient of this line, let's call a line L. The gradient of this line from this equation is negative 3. And so the gradient of this line is also negative 3. So the gradient of PQ from P to Q is negative 3. Now the gradient formula between P and Q is going to be y2 minus y1, which is 8 minus 2, y2 minus y1 over x2, which is 6 minus k minus x1, and that's equal to negative 3. All right. In order for this to be equal to negative 3, then what we have is, because 8 minus 2 is 6. 6 over 6 minus k is equal to negative 3. In order for us to divide 6 by something to get negative 3, then in the denominator has to be negative 2. And so 6 minus k have to be equal to negative 2. And so therefore, when you transpose and make k the subject, I bring the 2 over here, bring the k over here. So I bring over 2, and I get 6 plus 2. Wait. K has to, this denominator has to be negative 2. So I bring over that. I'm getting k is 8. 6, 8 don't sound right there. 6, 8 is the point. Yeah, k is equal to 8. The answer is there. It's just shocked for a second. So we bring over that and we get k equal 8. Because 6 minus 8 is negative 2. All right. So now that we have the point for k, k is the point 8. All right, easy stuff. Now question 25 gives us a parametric equation where they said x is equal to 2 sine theta and y is equal to cosine theta. To solve this question, first and foremost, we need to be able to connect x and y through the use of an equation which is sine squared plus cos squared is 1. And so it's easy to connect them. They told you that x is 2 sine theta. X is 2 sine theta. I'm just going to write t. T is for theta. X is 2 sine theta. And y is equal to cosine theta. And so if I were to divide both sides by 2 right here, I'd get x over 2 is equal to sine theta But then what do? I know that sine square plus cos square is 1. Sine square t, which is theta, plus cos square t is 1. That's equal to 1. All right? And then what is sine square? Sine square is just x square over 2 square, which is 4, plus cos square. Cos square is just y square. And that's equal to 1. So only thing left to do now is multiply through this equation by 4. And so what we're getting is x squared plus 4y squared, and it's equal to 4. That's it. What we did, we multiplied by 4. So x squared plus 4y squared is equal to 4. Here it is, C. Easy question. All right. So now the best topic again, vectors. They give us a vector equation, and they give us 2 parameters, s and t, and they tell us that this vector equation has a value of -5, 1, and it says find the value of s and t. The first thing you have to do when you're solving vector question is to simplify what is on the left-hand side by writing it as one vector and then equating their vector components, equating the x components and then equating the y components. And so let's go ahead now and simplify this. So this can be written as -2ss. So we're going to write that part as, can be written as -2ss. And then this part can be written as t. So we can write it as plus t, plus t, and plus t. And that is being equated to -5, 1. -5, 1. All right. And so the next thing to do now is to solve the 2 equations simultaneously. So we have -2s plus t, and that's equal to -5. And then we have s plus t is going to be equal to 1. So the first thing we can do is add the 2 equations. We can add the 2 equations. If we add the 2 equations, we get -3s t. Okay, let's subtract the equation. It looks smarter to subtract because we have plus and plus. So let's subtract the 2 equations. So if we subtract the 2 equations, we get -3s is equal to -6. So from this, we're getting s must be equal to 2. If s is equal to 2, 2 plus -1 is 1. And so t has to be -1. T is equal to -1. Easy, soft. So 2 -1 is the answer. 2 -1, which is D. All right. Now this question asks us for the vector. It asks us for the vector such that it is perpendicular. P and Q are perpendicular, and find the value of lambda. Now 2 perpendicular vectors, what happened is that their dot product is equal to 0. So we have P dot Q equal to 0. P dot Q is equal to 0. So we're solving P dot Q equal to 0. So that implies we're solving 2, 1, that lambda 6 equal to 0. That implies we're solving 2, 1 dot lambda 6 equal to 0. And so what we end up get is 2 lambda plus 6 is equal to 0. And so lambda is equal to negative 3. Therefore, lambda is equal to negative 3. Easy, soft. Lambda is negative 3. All right. Now, the next question is going to ask us now the distance meters of a reciprocating arm of a shaping machine from its starting position can be modeled by the equation 12 cosine theta plus 5 sine theta, and they want us to find the maximum distance from the starting point. All right, so in order to find the maximum distance of the starting point, you're going to have to write it in the r sine or the r cosine form. So this question, which is 12 cosine theta plus 5 sine theta, we can write it in the r cosine form. So d, which is equal to 12 cos theta plus 5 sine theta. We can write it in the r sine form. So it's going to be equal to r, or in the r cosine form, it's going to be r cosine bracket theta minus alpha. That's in the r cosine form, where r is going to be equal to 12 square plus 5 square all square rooted. 12 square plus 5 square all square rooted. So 12 square plus 5 square all square rooted, that's going to give us 13. And so the maximum distance is always r, so the maximum is 13. So that's all you need to do, and you get the maximum distance. Question 29 asks us for the general solution of the root 3 sine theta minus cosine theta. So there are two ways to solve this equation. So we have root 3 sine theta minus cosine theta. So two ways to solve it. So we have root 3 sine theta minus cos theta. That's equal to 0. So the first thing we can do is bring cos on one side. And so what we end up having is root 3 sine theta is equal to cosine theta. So if you have root 3 sine theta is equal to cosine theta, what you can then do is divide both of the sides by the sine of theta. So we're going to divide both sides by sine theta, and what we're going to end up get is root 3 sine theta over sine theta is just root 3. And then cosine theta over sine theta is cotangent theta. What is cotangent theta? Cotangent theta is 1 over tan theta. 1 over tan theta. And so if I have 1 over tan theta equal root 3, then the tan of theta is just going to be equal to, tan of theta is just 1 divided by the root of 3. So the tan of theta is 1 divided by the root of 3. And so theta is then just going to be equal to tan inverse of 1 over root 3. Tan inverse of 1 over root 3. So what's tan inverse of 1 over root 3? So tan inverse of 1 over root 3 is pi over 6. So go back to it. And so it's going to be n pi plus pi over 6. That's the general solution. How we know that it is n pi? Well, first and foremost, this gives us one answer. But we already know that tan is positive in 2 quadrants. Tan is positive in 2 quadrants. The 2 quadrants that tan is positive in is this one and this one. And so if this angle is pi by 6, the next corresponding angle is pi plus pi by 6, right? And when you're going around the circle n times, the corresponding angle is just n pi plus pi by 6. And so therefore, A is the answer. Easy, soft, easy like Sunday morning. Now this question is going to ask us for a unit vector. Once you see unit vector, start thinking about 1 over the modulus of. And so just look for which one of them as 1 over the modulus of. That's going to be a unit vector. There's only one right here. This is the only one that could possibly be a unit vector. So once you see the word unit vector, you don't, from you look at this, the others, these are actual vectors. This could be the actual vector u, but it can't be the unit vector vector u. Unit vector is 1 over the modulus of the vector times the vector itself. That's unit vector. And so C is the answer without doing anything. Question 31. Now looking at the diagram, we can clearly see that f of a is undefined. And so it asks us which of the following is not true. F of a is undefined, that is true. The limit as x goes to a of f of x is equal to f of a. Now that is not true. It doesn't have any limit. And so therefore B is not true. The limit as x goes to a does not exist. Yes, we don't know the limit. Because if it go to infinity, we don't know the limit. Limit is an actual value. So we don't know the limit. Now this question, I'm going to tell you a trick way to look at it. Anytime you see sine of x over x is 1, think of it this way. Ignore the signs. When x is very small, sine x approaches x. And so ignore. Imagine you never see the sine x. What you actually would see is 3x over 2x. X would cancel. And so what we have is 3 over 2. All right? So imagine it that way when you're doing multiple choice. So if I ask you for the limit of the sine of 5x over 4x, is just 5 over 4. All right. Now question 33. Question 33 is saying the function g is defined by g of x is equal to 3x plus 5 and px plus 2. And 1 is for when x is less than 3, and 1 is for when x is greater than or equal to 3. So it says for the function to be continuous at x equal to 3, what is the value of p, or what should the value of p be? All right. So what we need to do now in order to be able to find the value of p that makes this function continuous is that we need g of 3 to be equal on both the left side and the right side. And so what we're going to be solving is, 3 times 3 plus 5 has to be equal to p times 3, which is p3, 3p plus 2. So what this works out to be, bring the 2 over there, and so we get 3p is equal to, that's 9 and 5 minus 2, that's 12. So we get 3p is equal to 12, and so p is equal to 4. So p has to be equal to 4 in order for the function to be continuous. That is C. Now right here, they're saying that given that the function, and we're integrating from 2 to 5 of 4 f of x is 9, find the value of the integral from 2 to 5 of 3 f of x. So the integral from 2 to 5 of 4 f of x is 9. The integral from 2 to 5 of 4 f of x is equal to 9. So if the integral from 2 to 5 of 4 f of x is equal to 9, then you can divide by 4 to get the integral from 2 to 5 of f of x by itself is going to be equal to 9 over 4. That's 9 over 4. And so therefore, if we want the integral now, so therefore 3 times the integral from 2 to 5 f of x dx is 3 times 9 over 4. So that's going to be 3 times 9 over 4, 3 times 9 over 4. And 3 times 9 is 27. So that's just 27 over 4. 27 over 4. That is D. All right. Now what? 35. 10 more to go. Question 35. Question 35 gives us the portion of the curve y is equal to 2x, and we have the x being from A to B, and they tell us that the volume, we want to find the volume of the curve when it is rotated around the x-axis. So first and foremost, how we find volume rotated around x-axis? Volume rotated around x-axis is pi times the integral from A to B of y squared dx. This is volume around the x-axis. Volume is pi times the integral of y squared dx. That's volume around the x-axis. But then they told us that y is 2x. So y is 2x. And so since y is 2x, y squared is going to be, so in this case where y is 2x, so y is 2x. And since y is 2x, y squared is going to be pi times the integral from A to B. Y squared is then going to be 4x squared dx, because then that's going to be y squared. And so that's the volume. And so if we want to factor out the 4, we can write it as 4 times the integral from A to B of pi x squared dx. So that's the volume around the x-axis. So let's go to pi x squared with 4 on the outside dx. That looks like B. You have to check all of it. 4 on the outside, pi x squared dx. So that's B. 36. When you differentiate tan, we get sec squared. Now multiply it by the differential of 6x, which is 6. So we get 6 sec squared, 6x. That's an easy question. Now this question, we're going to have to apply quotient rule, where they're telling us that y is equal to x minus 6 over 3 minus 4x. So let's use some quotient rule now. X minus 6 over 3 minus 4x. So y is equal to x minus 6 over 3 minus 4x. All right, so to differentiate this now, we get dy by dx is equal to, so typically they tell you to write u and v, so you call the top u, you call the bottom v, and then them tell you that it's v du minus u dv. So v du, v is the bottom, so it's 3 minus 4x, v times du, du is the differential of the top, which is 1, minus u, which is the top, minus dv, which is the differential of the bottom, which is minus 4, over v squared, which is the bottom square, which is 3 minus 4x all squared. So we're going to go ahead and simplify this. So we have dy by dx is going to be equal to, simplifying it, we have 1 times 3 minus 4x is 3 minus 4x. And then what we're going to have right here is minus 4 times minus x. And then the minus out here make it become plus 4x. Then we're going to have minus 4 times minus 6. Then minus, that makes it minus 24 over the bottom square. And so the minus 4x plus 4x cancel each other. And so what we get is 3 minus 24, which is negative 21, divided by 3 minus 4x all square. So 3 minus 21 over 3 minus 4x all square. Minus 21 over 3 minus 4x all square. All right. We're almost finished. So this question gives us y is equal to the square root of 2x plus 1, and then they want d2y by dx squared. So y is equal to the square root of 2x plus 1. So y is equal to the square root of 2x plus 1, which is 2x plus 1 to the half power and so dy by dx is going to be equal to, we differentiate this by bring down the power, subtract 1 from the power, so bring down the power, then we subtract 1 from the power to get minus half, times the differential inside the bracket, which is 2. And so dy by dx is working itself out to be 2x plus 1 to the minus half. 2x plus 1 to the minus half. That's dy dx. So next thing we need is d2y by dx squared, because they said they want the second derivative. So the second derivative, d2y by dx squared, is going to be equal to, we carry down the power, then we subtract 1 from the power, so subtract 1 from the power to get minus 3 over 2 times the differential inside of this bracket, which is 2. So minus 3x over 2. Then the differential inside the bracket, which is 2. This 2 cancels this 2. And so what we end up get is minus 1 over, this works out to be 2x plus 1 to the 3 over 2 in the denominator, to the 3 over 2. Now, first and foremost, 3 over 2, I just want to write this down out there. 3 over 2 can always be looked at as 1 plus a half. And so in the denominator, we can write this as minus 1 over a half power of 2x plus 1 is the square root of 2x plus 1 times 2x plus 1. So that's the answer. Easy stuff. Soft. Minus 1. And so that's B. Question 39 is straightforward. They ask you, what is the gradient when x is pi by 6 for the curve sine x? So first thing, when you differentiate sine x, you get cos x, and you plug in pi by 6. So we want the cos of pi by 6. Now the cosine of 30 is root 3 over 2. So that's D. Question 40. Question 40, it says that we have a curve is defined by the equation y is equal to minus 5 times 1 minus 2x all square. And given that x increases at a rate of 1 unit per second when x is 1, what is the corresponding rate of change of y? So they're asking what is the corresponding rate of change of y. And so first thing they tell us what the rate of change of x is. And so we can always do this. dy by dt, which is the rate of change of y with respect to time. We're going to apply chain rule. It's going to be dy by dx times dx dt times dx dt. That's going to give us dy dt using chain rule. Now dx dt is 1, given that x increases at a rate of 1 unit per second. And so now we just need to find dy dx. So dy dx in this case is going to be minus 20 times 1 minus 2x. Because we bring down the 2 to get minus 10. We bring down the 2 to get minus 10. Then we times it by the negative 2 inside the bracket to get 20 times 1 minus 2x. So dy dx is 20 times 1 minus 2x times dx dt, which is 1. Now what do they want the rate of change of? They want the rate of change of when x is 1. And so all we need to do now is substitute when x is 1. And so when x is 1, when x equal 1, when x is equal to 1, what we're getting is this is equal to, we plug in 1 right here, 1 minus 2 is negative 1, negative 1 times 20 is negative 20. So we get negative 20 is the rate of change of y. Negative 20. That's it. So go to 41. Question 41 asks us for the integral of sec squared. When you differentiate tan, you get sec. And so when you integrate sec squared, you get tan. And so all we need is the tan of pi by 4. And the tan of pi by 4 is 1. That's a tan of 45 degrees. The tan of 45 degrees is 1. All right. Now, item 42. Item 42 gives us a curve and a line, and they're asking us for the finite region. The finite region, or the area of the finite region, is the area of the line minus the area of the curve. That's how we find the area. It's the area of the line minus the area of the curve. So it's always above minus below. And so what we're going to do is y is x squared and y is x. And so the area is equal to the area of the line minus the area of the curve. That's how we find the area in this case. It's always above minus below. Now the area of the line is the integral from 0 to 1. So the area of the line is the integral from 0 to 1 of x minus the curve now, which is the integral from 0 to 1 of the curve they told us is, I think, x squared. X squared is the curve, and so it's the integral from 0 to 1 of x squared. So when we integrate now, we add 1 to the power and we divide by the power minus, and we integrate that from 0 to 1, minus, we add 1 to the power to get x cubed, divide by the power 3, and we're going from 0 to 1. So what we're getting is a half minus 1 over 3 is the area. A half minus 1 over 3, which a half minus 1 over 3, that's what? 1 over 6. That's 1 over 6. That's 1 over 6. So half minus 1 over 3 is 1 over 6. So that's the finite area, 1 over 6. All right. So the area is 1 over 6. Into the final 3. So they're telling us the rate of change of y with respect to x is 3x squared plus 4 over x cubed. Then what is y? Rate of change of y is dy dx. So they are pretty much telling us that dy by dx is equal to 3x squared plus 4 over x cubed. So we have 3x squared plus 4 over x cubed. That's dy by dx. And so when we integrate this, we get y is equal to, how we integrate it, we add 1 to the power and divide by the power. So we get add 1 to the power, divide by the power, plus to integrate 4x cubed, we add 1 to the power to get 4x to the minus 2, and we divide by the power of minus 2, plus some constant of integration. And so what we end up getting is x cubed minus 2 over x squared plus c. So it's x cubed minus 2 over x squared plus c. That's it. Easy. That's question 43. Question 44 now. Now question 44 is pretty simple. It says a rod is heated and its length at T is given by L is equal to 5T squared plus 100. When T is 3, what is the rate of increase of L? And so the rate of increase of L, well, they're just asking you to differentiate L with respect to T. So L is 5T squared minus 100. So L is equal to 5T squared minus 100. And so what happened is dL by dt, that's going to be equal to, bring down the power, and that's 10 times t. All right, and they want the rate when t is equal to 3. So when t is equal to 3, we substitute and we get dL by dt. dL by dt is going to be equal to 10 times 3. 10 times 3, which is 30. So dL by dt is 30. And that gives us the rate when t is 3. Finally, the last question, it says a rope of length k meters form 3 sides of a rectangle. And they said, then the area R in the rope forms three sides of a rectangle with width x, then the area r in the square meters of the rectangle is given by r is x times k minus x squared. Find the maximum value of the area. So, pretty easy question. So let's just look at a sketch of what's happening. So here's a sketch of what's happening. I'm going to draw a rectangle. And they tell me that the rope forms three sides of a rectangle. The rope of length k forms three sides of a rectangle. And the area of the rectangle is x times k minus x. So the width is x. The length is k minus, what's the length? K minus 2x. K minus 2x is the length. That's the length, k minus 2x. All right, and so this side is x. And so the length of the rope, type in the length of the rope. Remember, it forms, this is the length of the rope, x plus this plus this. So the length of the rope is just x plus k minus 2x, which is k. That's the length of the rope. So when I say length, I'm talking about the length of the rope. Now r is equal to x times k minus 2x. All right. And so the maximum value of the area occurs at turning point. And so we just need to find dr by dx. So dr by dx is equal to, if you were to expand this is really xk minus 2x squared. So when you differentiate xk, you get k. When you differentiate minus 2x squared, you get minus 2x squared, you get minus 4x. All right. So this is when you're going to get maximum area, and that's when this is equal to 0. So we have k minus 4x is equal to 0. K minus 4x is equal to 0. And so k is going to be equal to 4x. So this is when we're going to get maximum area. So we get maximum area when k is equal to 4x. If k is equal to 4x, then r, so from this, let's carry it right here, then r is going to be equal to x times k minus 2x. So it's going to be x times k minus 2x, which is 4x minus 2x, which is 2x. And so that's 2x squared. That's the maximum area, 2x squared. Oh, they want it in terms of k. So they want the maximum value in terms of k. So let's do everything by making k the subject. So let's make k the subject instead of x to get it in terms of x. Well, actually, we can even just substitute from right here. So from right here, x is k over 4. So if k is 4x, then right, x is going to be k over 4. That's what x is going to be. And so the maximum area, plug in x as k over 4, is going to be 2 times k over 4 squared. And so k over 4 squared is just k squared in the numerator. So we have 2k squared over 16. 2k squared over 16. If you want, you can simplify it, because then that's just going to be k squared over 8. So k squared over 8. A. And that's the maximum value of the area. All right. And so pretty much wraps up 2009 paper, and 2010 is similar to 2009. All right. So, Errol, can you hear me? Errol.